why is like the smallest little bit like the hardest to get to?
Longhorn Rocketry Association is a high-power rocketry organization that specializes in
IREC this year. Our goal is to launch a...
Simulations are important because it gives us usage of inbuilt barometers and IMUs.
This year our goal is to hit 30,000 feet with our rocket.
Our Seymour launch, our test launch.
the tallest peak on Mars. Introducing Olympus.
This year our goal is to hit 30,000 feet with our rocket, test the viability of a boat tail on our rocket, live stream video directly from the rocket, and with our payload to reconstruct the local topography and to monitor the oxygen production of algae during flight.
And we also, for this year's rocket, we wanted to make sure we had a good mass budget, so we're keeping track of all our masses, unlike last year's design where we didn't really account for that. And then there were also some different internal components that changed, such as our electronic system being expanded to include a live video component.
So the biggest challenges that we've faced this year are, for our Rocket Pi team, we were having trouble making sure our center of mass and center of pressure matched the open rocket. We didn't know the exact grain placement and grain density of our propellant in our commercial off-the-shelf motor. So we had to interpolate and really just like guess and check our way into an accurate simulation.
The way we go about testing to see if the student-made flight computer is able to do what's supposed to do is by putting it in a vacuum chamber. This allows us to see the change of pressure, which gives us a sense of a change of altitude, allowing us to simulate what we can expect during flight.
So our 2025 payload is called Apollo, which stands for Algae Photosynthesis Observation and Long-Range Land Observations. And essentially we've combined two experiments in one. So first of all, we are monitoring a sample of algae to see how much oxygen it produces throughout our rocket's flight. And this can be useful in rocketry application to see how we can artificially produce oxygen in more long-term space missions. Apart from that, we have two cameras that are set up to observe all the land and terrain around our rocket, which can later be developed into an experiment with OpenCV or some mapping terrain software to give us insight into what the rocket is seeing.
And this is the first year we've been put onto flight systems. And so what that entails is the fact that we are doing external flow simulations of our rocket, and we have created an alternate flight dynamics software using the Rocket Pi library. None of this existed last year.
We'll send UT Austin in 3, 2, 1. There she goes.
So from our Seymour launch, our test launch, we had to make many changes to our current Olympus design. So the main things that failed for our test launch were the attachment methods for the payload and electronic system, the parachutes, and there was some light damage just from the launch. So the first things we changed were our attachment method. Before we were using like long screws and just normal nuts just glued onto the tube. Now we changed it so they're pressed into wood and then glued on. We changed our parachutes because one broke, or the drogue broke, and the main parachute had to be was borrowed, so we had to buy a new one. The electronic system changed, and we patched up some of the damage for the rocket that was caused by the test launch. Then lastly, what we're trying to see at Spaceport is just faster integration of Olympus and then a smooth recovery afterwards.
Next stop, Midland.
Let's go, everybody!
We choose to come to IREC every year because we're able to put unique and new things on our rocket, like trying live video, put on a boat tail, and try to see how far we can push our design. We talk to other teams, learn from their successes, their failures, and try to replicate it on our rocket and see how far we can take.
So here for some post-flight analysis. You can see not the prettiest launch or the prettiest recovery.
Things didn't go exactly as planned. We had a bit of off-the-rail instability, which we're currently investigating. The airframe fractured at both of the couplers, so we're going to try and come through the data, see if we can figure out what caused the off-the-rail instability and caused the airframe to fracture.
IREC will see you next year! Woo!